A solid block of steel handles a high-powered anti-gravity lift with ease. The metal is rigid, it accepts the force and rises. But a melon placed in that same field distorts, compresses, and violently ruptures. Solving this disparity is the primary mission of the Woomera test facility in the Australian desert. This site serves as the proving ground for the protocols that will eventually govern lunar shipyards. But before any construction can begin, engineers have to figure out how to move a pressurized human body without destroying it. The problem is inertia. When a lift field activates, the rigid outer container moves upward instantly, but the fluid inside lags behind. For a fraction of a second, that liquid mass resists the acceleration and slams into the bottom of the rising container. Early tests used melons because they roughly approximate human biology. They are heavy, wet, and encased in a semi-rigid skin. In every trial, the outer rind remained intact, but the shock wave traveling through the interior left the fruit pulverized. Since a human body becomes soup under G-force spikes that a machine wouldn't even notice, the team abandoned traditional cargo tests. They built Charlie, a sensory-heavy mechanical analog designed to generate the specific data needed to keep a passenger alive. Charlie is a sensor-packed Goliath. His frame contains a jointed spine, weighted limbs, and fluid-filled bladders positioned to mimic the specific vulnerabilities of human lungs, heart, and gut. During early lifts, Charlie's sensors recorded a recurring failure mode. As the lift field engaged, his internal mass hesitated, creating sharp pressure spikes that the engineers began to call jagged teeth on the telemetry line. This is gut lag. Because there is a slight lag between the container and the contents, the abdominal bladders rupture. The dummy arrives in one piece, but internal fluid dynamics have caused a catastrophic failure. These results demonstrated surviving a mechanical lift is irrelevant if the internal pressure spikes cause fatal vascular stress before the brain even registers the movement. The 17th test attempted a simple 50-foot ascent. The lift began perfectly, but at 32 feet, the neck sensors recorded a sudden, violent resonance that the automatic safety cutoffs weren't fast enough to stop. The control system had attempted to predict Charlie's next movement, applying damping for a future position before the dummy had finished its current one. This anticipation error caused the head to snap forward with enough force to break a human neck. To mark this failure, the team painted a red C-17 on Charlie's chest. It is a permanent reminder of the time the machine tried to be clever and guess. This test established a new requirement for the Woomera program. Predictive algorithms are prohibited. Because biological responses are chaotic, the machine is never allowed to guess the next move. It must listen to the load in real time. Solving the anticipation error required negative feedback, housed within a cradle within a cradle. As shown in this nested wireframe, the system uses flexible ribs and fluid buffers to read Charlie's mass in real time. If sensors detect the load resisting, the platform instantly eases the field. This responsive system answers the pressure wave before it peaks, flattening the jagged teeth on the graph into a smooth rolling wave. The breakthrough wasn't a more powerful machine, but a system that meticulously smooths the physical transition so the human body doesn't have to absorb the shock. The team eventually pushed Charlie to a 5,000-foot hold. Using the new listening cradle, the dummy rose and returned to the pad, with its internal sensors finally remaining within survivable tolerances. The final medical telemetry suggests that a human taking this ride would be bruised, nauseous, and certainly frightened, but they would also be conscious and alive. Woomera refused to call this a total success. They logged the trial as a recoverable biological equivalent, a classification that acknowledges survival without claiming the ride is comfortable or safe. These earthly desert trials are the prerequisite for the lunar shipyards currently in development. By defining these protocols now, the engineers ensure that when massive sections are lifted in a lunar yard, the systems will already know how to handle the slosh and lag of the human crews inside. Every red mark on Charlie's chest represents a mistake that won't be repeated with a living passenger. By meticulously mapping every failure mode in the desert, Woomera is teaching its machines to respect human fragility before the first voyage ever begins.